Assalamu alaikum everyone. I am Shobhan Chakraborty, ID 22366023. I am here today to describe about our project by LSTM NN based employee job satisfaction analysis from Glassdoor data using web scraping. At first, you can see the author list of our research paper. Our first member is Mohammad Yasin Morshid Arif. Second member is myself, Shobhan Chakraborty. Third member is Munim bin Mukid. And finally, thanks to Mr. Anajat Alim Russell, sir, for supervising this project. At first, we would like to see the abstract of our research paper. Here in this paper, we are suggesting a hybrid model named PyLSTMNN. We are using this model to analyze the employee job satisfaction of Bangladeshi IT sector employees. In this paper, we have considered 12 renowned IT and software companies of Bangladesh. All the reviews posted by the employees of these organizations are usually posted in glassdoor.com. Initially we scrapped these reviews from the glassdoor.com, which is a USA based software or web application. After that, we have built a specialist data set to store the collected data. Necessary pre-processing has been completed. After that, we are proposing a model that shown a good accuracy, precision after feeding the collected data to this model. We also compare the trainable parameters with the state-of-the-art models, and we have found our model performing better or outperformed other models in terms of different evaluation matrices. And here we have considered 5 polarity values, which are super positive, positive, neutral, negative, and super negatives. At first, we have written the introduction of our research. Here we have shown the state of the why we are doing this. What's the purpose of this research? That's why if we go to the options, we already described at the beginning of the introduction sections that how many works has been done by the researchers using Glassdoor data, how important the employee satisfaction are. Even we have found there is no work done based on Bangladeshi employee job satisfaction reviews. That's why we have chosen this project. The major contribution of these papers are given below, which are we are proposing a BILSTM NN-based architecture that can detect sentiments of an employee more efficiently than the state-of-the-art architectures. The job market of Bangladeshi IT and software sector, along with understanding the perspective of the attached employees, price increases are a recurring phenomenon and wages are insufficient to cover expenses. The analysis can also help studies about changes in human behavior patterns. And finally, we have built a specialized dataset and that is preserved for further utilization in the concerned research field. So this is the contributions of a research paper. Apart from that, when we went to the literature review section, we have reviewed almost 10 to 12 papers for these sections collected from renowned journals and conferences. We have found some major research gaps. The research gaps are there is no previous work based on employee job satisfaction in Bengali language, even if there is almost no research happen based on hybrid architectures in Bengali sentiment analysis. So that's why we grow our interest in this sector and we work for this. The methodologies for research methodologies, we have considered some following things. At first, we have set our programming environment. That's why we have used Python 3.10.8, which is the recent version. And we have used TensorFlow, Keras, and Matplotlib and Seaborn for drawing different diagrams. And for the dense layer and deep neural network architecture, we have used Keras library. So at first, our target is to web scrap the data and found out how this scrapping is done and worked. So that's why for scraping, we have used beautiful soap to extract data from HTML and XML. After scraping, open source neural library Keras is applied. Theano, Microsoft Cognitive Toolkit, and paid ML, all of them are utilized for various purposes. If we look at the proposed methodology, we can see we have gathered the comments, we have performed the pre-processing. After that, we have gained the or obtained the clean data. We have split the data into training set and test set. After that, we fed the data to the proposed by LSTM NN model, and we evaluate the performance and compare the model with the state of the art architectures. So now we would like to have a look at the dataset descriptions. So we already mentioned we have used a scrap dataset from Glassdoor. For that, we have used the HTTP response URL libraries. And in case of URL libraries, we posted the link there. In return, they gave us a HTML page. The HTML page are further utilized using Beautiful Soap library, and we obtained the uh, organized data. Now, while scrapping, we have considered three things, especially polarity of a company, rating of a company, and name of the company. For confidential purposes, we are not revealing the name of the companies, but when we get a get a review of rating 5, we usually assign super positive polarity. When we get 4.0, we usually assign positive polarity. In case of 3, we assign neutral. In case of 2, we assign negative, and in case of 1, we assign super negative. We also considered another dataset called Amazon Product Review dataset, which is available at Kaggle for observing the result of our model. So in case of data pre-processing, we have erase punctuation marks. All the examples are given here. Converting all the letters into lower cases. We have removed stopwords, hyperlink, emojis. After that, unnecessary spaces. Then we tokenized all the necessary data. Then we used fixed length padding, which allow us to have the same shape for every sentence. We have performed word embedding to convert the data into numerical formats. After that, we have suppose we have a review of rating 4.2. We have then if in case of 4.2, we convert it to 4. In case of 4. Values above 4.5 and 4.5, we consider it as 5. The proposed model methodology or the proposed model. In case of the proposed model, you have a detailed look of our bi-LSTM architecture, which we have used. After that, all the hyperparameters are fine-tuned, where we have used maximum length 24, learning rate 0.001. We have for the introduction of non-linearity, we have softmax and ReLU. Activation function, we have used binary cross entropy loss function, and for ignoring overfitting, we have applied dropout. And we have split the data set in a 70 and 30% ratio, 70% for training and 30% for validation or testing. So you can have a detailed look in figure 3 about our model, which is we initiated our model with a sequential layer, then we performed word embedding, spatial dropout, we have used 120 bi-LSTM layer, then we flatten, then we have initiated 3 fully connected ANN layers, and finally an output layer. Now we will come to the result analysis and discussion section. We can see when we compare the F1 score in case of scrap dataset, it is observed that our proposed model achieves 88.64% F1 score accuracy, where maximum is 73.15 previously in case of machine learning models. In case of deep learning models, we can see that the F1 comparison is 88.64% on the same data set, where previously we have used BiLSTEM CNN has more accuracy. In case of trainable parameters, it can be observed um, our model by LSTM NN has the lowest amount of parameters than other models. So the reasons we have used is BiLSTM CNN is because the CNN has we have observed or analyzed we have performed an analysis why our model is performing better because the nearest model that have performed better is BiLSTM CNN, but in case of CNN the complex problem learning is quite tough and proper parameter tuning is also tough. In case of computer vision related problems, CNN is better, but where complex pattern exists, NN usually performs better. That's why we think that our model performs better than other models. Finally, we have to we have fed the Amazon product review dataset to our model. Also, we have also found that our model performed tremendously than other models where the accuracy, recall, and precision for each segment is given sequentially in this table. And finally, we believe we have proposed a good amount of data. We'll gathered a good amount of data for reviewing and fed into the deep learning models. In future, we'll propose another model or we'll work with this model to fine tune hyperparameters for achieving more accuracy and observe the results and another model to investigate to compare this model with other more models also. Thank you everyone. Thank you.